Okay, so what we're doing here is we are identifying all the different expressions that are equivalent to the following expression here. So the first thing that you need to do is you need to put this one in simplified form by combining any like terms that you have. So we know that we've got like terms with our variables. We've got 16x and we've got a negative 24x. So we can combine those together. 16x minus the 24x, that's going to come out to a negative 8x. And then we've got our constants. Our constants happen to be a negative 12 and a positive 4. So if we take negative 12 and plus 4, that's going to come out to a negative 8. So we're looking for expressions that when they simplify, they look like negative 8 minus 8. Okay, so if we take a look at problem A, so I'm going to split these up into sections so that we know what we're solving. For problem A, first thing that I need to do is my distributive property. I need to multiply negative 12 to this positive 1 and to this positive 2x. So I'm doing negative 12 times 1 and negative 12 times 2x. Negative 12 times 1 is going to come out to negative 12. Negative 12 times 2x comes out to negative 24x. Okay, we still have everything else that's written out in the front, so we still have 4 plus the 16x. No, not right now. Okay, so now we've got 4 plus 16x minus 12 minus 24x. We can then go ahead and combine our like terms. We have a positive 16x and a negative 24x that can be combined together. 16x minus 24x comes out to negative 8x. So far so good. Then we have a positive 4 and a negative 12. Positive 4 and negative 12, that's going to come out to negative 8. So that is the exact same expression as what was above. So this works. This is going to be one of our answer choices that would work. We're looking at problem B. We can't simplify problem B. That's as simplified as it gets, and it is not equivalent. So that is not going to work. Problem C, that can be simplified. So we can combine our like terms. That's 16x minus the 24x. That can get combined together. When we combine those, that's going to come out to a negative 8x. So far, so good. Then we've got a negative 4 and a positive 12. Well, when we simplify that, that comes out to a positive 8. That's not the same thing as a minus 8. It's not the same. Okay, this part is not the same. So therefore, it will not work. And then answer choice D is already as simplified as it's going to go, and it is identical. So that works. So answer choices A and D are equivalent. In situations like this on tests and interims and all sorts of wonderfulness, you have to work out every single answer choice to see which ones will work. It's not going to be a simple, oh, let me work out just the problem part. You actually have to work out each of the answer choices to see which ones are working and which ones don't work. Okay, let's take a look at problem number 2. For problem number 2, it says Mrs. Donaldson's class is planting a rectangular vegetable garden. The dimensions of the garden are shown below. So we have half of an x minus 7, and then we have a 6. We want to go ahead and show perimeter of this garden. So we're not focusing on volume, we're just focusing on the perimeter of the box. Okay, so that means that we need to understand perimeter first. What does perimeter mean that we're doing? When we say perimeter, what are we doing, guys? Huh? Not multiplying. Multiplying is area. What are we doing with perimeter, Harper? Adding. We are going to add. We're going to add all the sides. In this case, how many sides are there for this rectangular box? More than 2. 4. It's a rectangle. Rectangles have 4 sides. Rectangles can have 4 sides. So that means you have 4 sides that you're adding together. So yes, we have this side as a half of an x minus 7. Across from it is also half of an x minus 7. On this side, we have a 6. On this side, we have a 6. Okay, so you have a rectangle. You have to add all of the sides together. Okay, so we've got to add our half of an x minus 7 plus the 6 plus half the x minus 7 plus the 6. Okay, now we can just focus on combining those like terms. We have half of an x plus half of an x. What's half of an x plus half an x going to equal? What's a half plus a half, guys? A whole. Okay, so it's 1x. Do I have to write the 1x? Do I have to write the 1? No, I could just write x. Okay, then we've got a negative 7 and a positive 6, a negative 7 and a positive 6. Okay, when I add all of that together, that's going to equal a negative 2. And there's my final answer. I get x minus 2. 1x minus 2, or just x minus 2. All right. We're translating expressions today. We're translating from words to values, words to actual expressions. Okay, so we have to have an understanding of those operations, adding and subtracting, multiplying and dividing. So go ahead and flip your paper on over to the back. We have a list of words that you need to make sure that you understand represent addition or subtraction or multiplication or division. Okay, so starting off first with our addition words. So for addition, we have sum, we have together, we have plus, add or added to, increased, and more than. Now, there's a couple of key things that you need to understand. The word sum, around the word sum, I want you guys to go ahead and put parentheses. Around the word sum, you're going to put parentheses. Because this means it's an answer to an addition problem. When I say the sum, I'm talking about the answer to an addition problem. So if I'm doing something to the sum, I have to put that sum in parentheses first, and that whatever I'm doing to it is outside the parentheses. So that way I know I have to find that sum first before I can do anything else. That's very key. Sum needs to have parentheses around it. Another really important one is the words more than. More than is what we like to call order reversing. So we're going to put this in purple. It is an order reversing word, the term more than. And what that means is if I were to say you have 7 more than x, then I am taking x and I am adding 7. It reverses the order of what's been stated. 7 more than x means x plus 7. You have to make sure you understand that. This is a very important one. This is the kind of thing that people get wrong all the time. And it doesn't make as much of a difference with addition as it does with subtraction. Subtraction also has some order reversing words. So let's take a look here at subtraction. So for subtraction, we have the words difference, take away, minus, subtracted from, decreased, less than. Okay, difference. I want you to put parentheses around the word difference. That also is a problem in which you have to do the difference first because it is an answer to a subtraction problem. So that means that you have to work that difference out first before you can do any other operations to it. It is the answer to a subtraction problem. It needs to be worked out first before you can do anything else. So we put it in parentheses to showcase it needs to go first. And then the term less than. Less than is also an order reversing word. And this is the kind that it does matter. The order that you write a subtraction problem does matter, because 7 minus 2 is not the same thing as 2 minus 7. One of them is positive, the other is negative. So the order does matter that you subtracted. So again, if I say 7 less than x, then I mean I'm taking x and I am subtracting 7. Very important. Fahim, you might want to copy that down. Because me saying this over and over and over again and you still focusing on your pencil is not going to help you. All right, then you've got multiplication and your division problems. So for multiplication, keywords are things like the product, times, multiplied by. Twice and doubled means you're multiplying it by 2. Triple means that you're multiplying by 3. Okay, so you need to understand those things. These are times 2. This is times 3. We don't have any order reversing words for multiplication, so that makes it kind of easy. Same thing for division. We don't have any order reversing words for division either. We just have the words quotient, divided by, taking half or taking a third. If you're taking a half, you're dividing by 2. If you're taking a third, you're dividing by 3. If you're taking a fourth, you're dividing by 4, and so on and so forth. Now, that's different. If you're taking 2/3, then you'd be multiplying by 2 and then dividing by 3. Okay, so it's a little bit different there. But we also know that as the of words, which means to multiply by a fraction. All right, so let's take a look at problem number 1. 6 more than x. 6 more than x. First thing that I need to identify is what does more than represent. Is more than addition, subtraction, multiplication, or division? Addition. So I'm going to go ahead and highlight that in my pink. I'm going to look up here as well and notice that this is the one that I starred and said it was order reversing, which means whatever was in the front is now going to reverse itself with whatever was in the back. So they are reversing their orders. X is going to come in the front, 6 is going to go in the back, and it's an addition problem in the between. So 6 more than x means x plus 6. All right, the word twice. Twice. Twice x. What does twice mean? What operation is twice? Multiplication. And it's specific multiplication. It means we are multiplying by what? 2. So we have 2x. Okay, I want you guys to do number 3 and number 4 on your own, please. All right. 2 less than triple a number. Who wants to tell me what they put? Madison? Okay. Good operations, wrong order. Remember, less than means what? Means subtraction, but it is order reversing, right? Less than is an order reversing, so you had to flip that order. So instead of 2 minus the 3x, you should have put 3x minus the 2. So let's write that down. Make sure you understand again, guys, less than, that term less than is going to get you in trouble if you don't follow the ordering. You do need to reverse your orders. So you're taking the 2 and you're taking the triple a number and you're going to reverse their orders. That means the 2 is going to go in the back. The triple a number is going to go in the front. And again, triple a number means that it is multiplication. So we have 3x that's going to go in the front. And then it is subtraction. So we are going to subtract. So it's 3x minus 2. 3x minus 2 is not the same thing as 2 minus 3x. They will give you one positive, one negative. Okay, number 4. 8 times the difference of x and 2. 8 times the difference of x and 2. Anybody want to try that one? Okay, Mackenzie. Okay, good. Parentheses, she put x minus 2 in the parentheses because it is the word difference. Remember, difference does mean that it needs to have parentheses around those values. So you're putting parentheses around the x and the 2. Okay, and then you're doing 8 times that. So 8 times, that is multiplication. You could put times 8 on the front or on the back. It doesn't matter. I'm going to go ahead and put it in the front because that's typically what it looks like, right? Most of our distributed property would be in the front. So you have 8 times, and then in parentheses, x minus 2. All right, any questions? All right, let's go ahead and go on to the next page. Yeah. Y is what? Less than? Why is it order reversing? Because it's saying that you're doing this much less than something else. So when you're saying I'm, like if I say, how old are you? 12? Okay. Whew. We're going to lie about my age for a second. We'll say that you are 22 years less than my age. So are you going to do 22 minus my age to get to yours? No. You would take my age, subtract 22, and you would get your age, right? So you have to realize that the order is going to determine how you're doing your subtraction or how you're adding. When you're saying that you're doing something less, you're doing something less than this value. So that means you're starting with this value and doing less than that, okay, or more than that. So when I say, oh, I've got, 7 more than x, it means I am starting with my x and I am adding 7 to it to make it 7 more than it. Okay? Does that make sense? Okay. All right. Go ahead and flip it on over to the back. So not all of our translations are going to be from straightforward, oh, it's 6 less than, 25x, whatever it might be. You are actually going to have some that are in context, some actual real world examples in which you have to write your expressions from. So let's take a look at problem number 5. It says Kyla wants to buy a DVD player. She already has $25 saved up, and she plans to save $10 each week. So we want to write an expression. So we have a couple of things that are happening here. We have an amount of money that she's already currently got saved, and then we have an amount that she's going to save every single week. This amount that she already has saved, we like to focus on that as being the constant. So your constant is your one-time value. It's something that you start with. It might be a fee that's going to occur or a starting point. So in this situation, that's going to be that $25. Okay, we started off with $25 saved. Now, from there, so in my problem, I've got 25. From there, I'm going to continue to save $10 each week. So this 10, the fact that I see this word each, the word each indicates that I'm dealing with a coefficient, which is my 10, and a variable, which is the weeks. So you have a number per, or a number each, or a number every something. Then that number is your coefficient. Per, each, or every is indicating that you're dealing with a coefficient and variable. Okay? So here, write this down again, our coefficient. We're going to look for words that are per, each, and every. It's the number that is attached to that per, each, and every, which in this case happens to be the 10. And then your variable is a part of that per, each, and every, which in this case happens to be the weeks. So we'll use the variable W. Now, if she's going to continue saving, does that mean that we're going to add or subtract? She's going to continue saving. Are we going to add or subtract? Add, right? So we're going to add $10 per week. And that's our expression. 25 plus 10W. All right, let's take a look at problem number 6. It says Jay has $50 on a gift card. She wants to buy a set of pencils for her friends. The set costs $6 per case. We're going to write an expression to show how much she will have left on the gift card after she purchases the pencil sets. Okay, so we have an amount that we're starting at, right? Remember we said our constant is a starting point. She started off with $50 on that gift card. So that's going to be our constant. So we're starting off with 50 on the gift card. She's going to buy pencil sets for each of her friends, and it's $6 per case. So 6 per case. So we have the word per. The number is representing the coefficient. The item after it is representing the variable. So the per is going to have the number before it, the item for our variable after. So our coefficient in this case, and I'm just going to put COEF. Our coefficient is going to be a 6. Our variable has to be the case. So what letter should we use to represent case? C, right? Let's let C represent our case. Okay, so we know we're dealing with 6C. So now, are we going to add or subtract in this situation? So now that's what we have to figure out. We have money on a gift card. We're going to buy items. Is that going to be adding or subtracting? Subtracting, right? When you're paying for items, you're subtracting money off of your gift card. So this is going to be a subtraction of 6C. Start with your 50. You're subtracting 6C away. That's your final answer. Go ahead and do number 7 on your own. So Jessie has 150 cookies to sell at a bake sale. She sells the cookies as 3 per pack. We're going to write an expression that represents how many cookies she will have remaining after she sells P packs of cookies. Okay, so when we started off, our constant was what she starts with. She has 150 to start with. That's our constant. So we're starting off with 150 cookies. Then she's going to sell 3 cookies per pack. So there's our coefficient and our variable. Our coefficient is going to be the 3. Our variable is representing the pack of cookies that she's going to sell. So we'll have a P. And we're going to be subtracting these away from the 150 cookies that she has to find out how many she's still going to have remaining, right? The keyword remaining. Remaining means we would be subtracting. And then there's our expression. Okay, loaded into Google Classroom, you guys have a quizzes that is going to have you translating. You're just translating from the words to the expressions.